All right, so we are going to run through our station lab today for the different physical properties. First one is just a simple density lab, and this is something that we're probably pretty handy at, but we'll run through the process as well. And what I have here is an unknown uh, metallic ball, and I'm hoping to find out, use my physical property to help identify what it is. I know that on my list of options, it's either silicon, aluminum, nickel, silver, or lead, based on what density I find, and we're going to try to make that determination. I've got my graduated cylinder filled up to 10 milliliters to find the volume, but I'll start out by finding the mass of my object. And if I put the cup on here, I hit my tare button, it'll go back to 0. So now when I put my object in and weigh it, I see my mass is 11.79 grams. All right, so 11.79 grams for my mass. Then I need my volume. So we'll take this out. I will try and carefully drop this into my graduated cylinder. Roll it in a little slow so we don't splash too much. All right, and then when I read my graduated cylinder, it looks like I went up 3 of the lines. Each line is 0.5 milliliters, so I went up 1.5 milliliters in that process there. So my volume is going to be 1.5. Density then, of course, is going to be my mass divided by my volume. So I'll plug my numbers into my calculator. My mass is 11.79 divided by 1.5, and I get 7.86. Now I realize that this is not going to be a perfect measurement, especially the volume is tricky to get extremely precise with the graduated cylinder. But if I look then and compare it to what my options might be, see which one is closest. I've got my silicon is 2.2. That's not particularly close. Neither is aluminum at 2.6. Nickel is 8.9. Now we're getting in the ballpark. And then everything else is bigger than that. Silver 10.1 and lead 11.2. So I'm going to make my determination that my closest answer is going to be nickel, based on the data that I gathered. All right. Next station is going to be testing the property of conductivity. And to do that, I need a new little apparatus. I have set up for me here a little multimeter. And then I've got a couple of electrical probes and wires that I can set up on either side of things, and I can measure my conductivity of some different materials. All right, and it tells me in the directions to set it to the 1 amp setting, which I currently have. Okay, and if nothing shows up from that, then I need to adjust to go to the milliamp setting. The first material is asked me to test is silicon. Here's a piece of silicon. So I'll simply put the probes on either side here and see if I get anything show up. Nothing really going through here right now. So I'll switch it over to the milliamp setting and see if we got milliamps going through there. So silicon, as metallic as it looks, really is not allowing a lot of conductivity. I can try on opposite sides. All right, but still very little coming from the silicon. And so that is silicon, just showing you that metals, or what looks to be a metal, can be deceiving at times. Next, it's going to ask me to measure the pencil marking. So I got some pencil on a sheet of paper here, and so my current for that, again, I'll start at my 1 amp setting, but not get anything there. I switch it over to my milliamp setting. Oops. I think we're having a problem here with my let me switch this out. I wonder if my batteries have died here. Let me try that. Try our silicon again. Make sure it wasn't just my battery here. Well, now we got a little something happening. You see, it's going to register here now on my 1 amp setting, and it goes to, hard to read exactly. Does it maybe 0.2 amps? I can get it up to go through there. That looks more like it. So for my silicon, I'm going to have 0.2. For my pencil marking, I'll hold her on either side. Get my multimeter in the screen here. Don't see much. Let me switch it to milliamps. Now I start getting a little bit of a reading. Going through there, it's registering a little bit there. Just probably about maybe 0.2 milliamps. The first one measurement was in amps. Second one was 0.2 milliamps, which of course is 1,000th of an amp. Now I'm going to do my water. And a lot of times we hear about water being a good conductor of electricity. Well, let's test it out a little bit here. Pour some water in my dish. Amp setting. I put them in. Don't really get much of anything. If I flip it over to my milliamp setting, now I got it going. If I try my salt water, try my amp setting, see if we can get anything on there. Now we see it shows up even on the amp setting here with the salt water. Okay, the salt water registering maybe just about 0.1 amp, but that's still a lot more than what the regular tap water was showing. So we went off the chart for the in milliamp setting for the water, and just about 0.1 amp with the salt water. All right, what do you think determines the conductivity of a substance? Well, that has to do, again, with how tightly held those electrons are, because electricity is moving electrons, and some materials hold on to those electrons real tightly and they become insulators, whereas others allow electrons to move a lot more freely. How tightly electrons are held. Next up then, I've got my magnetism set. And this one really goes fast. But just testing the magnetism of a few items here. Starting out with a metal bar. Got this metal bar. I'm going to see if it attaches to a magnet here. We'll see we really don't have any attraction there. A lot of times, of course, the assumption is, well, if it's metal, it's going to get attracted. But clearly that's not necessarily the case. Next up, I've got my paper clips. And my paper clips, well, they grab onto the magnet very readily, as we'll see. So I can put a check mark in with the paper clips. How about the aluminum foil? The aluminum foil. Aluminum of course, is a metal we use a lot, but is it magnetic? You see, not. There's no attraction at all to the aluminum foil. Silicon, which we just used a minute ago, we can check that out. Once again, no magnetic attraction there either. And then, last but not least, I've got a couple of little steel balls. And obviously, you see that they readily attach themselves to the magnet. So, I'll check that. Obviously, all metals are not magnetic. Again, in fact, there are only 3 naturally occurring magnetic materials: iron, cobalt, and nickel. All right, and so when you see something that does attract to a magnet, you know it's going to have one of those substances in it. Okay, either iron, cobalt, or nickel. Those are our 3 elements that will attach to magnets, and those are the chemical symbols for them. Last but not least, I'm going to do our little solubility test. In our solubility test, it's going to ask me to find the, adjust here a little bit, glare right now, but it's going to ask me to tear the mass of a graduated cylinder. Okay, and that's just going to allow for me then to very easily get my other measurements in there. And as I say, add 10 milliliters of water. All right, so I'm going to there's 5. And now I got to my 10, so I drop it on my scale there, and I'm at 9.37 grams. So right about 10 milliliters. You know the density of water you knew was going to be close to 10 as well there. So for the mass of my water, I'm going to write in 9.38. The volume of water, of course, I've got 10 milliliters. And now it's going to tell me to add some salt here. I'm going to do that in a test tube. And a test tube, of course, is not the same thing as a graduated cylinder. This is going to be a test tube. All right, so I'll pour my water into my test tube. And then it's going to ask me to try and saturate the solution. In other words, I'm going to try and add salt in here until it can't dissolve anymore. I'm going to dissolve as much as I possibly can. All right, so I'm going to drop some salt in there. And when I first just drop it in, it settles to the bottom real quickly, but sometimes you need to agitate it a little bit. And if I hold it at the top of the test tube and tap it, what I'll do is I'll get more of that salt to be able to dissolve. And so a lot of that excess that was at the bottom now is gone. So I'm going to add some more in here. Again, I want to try to dissolve as much as I possibly can. Really pretty much dissolved all that away as well, so I'm going to add a little bit more. See if because I want to have some excess at the bottom. I want to know that I've dissolved all that's possible. All right, now I'm seeing some start to form there, a little leftover that wasn't able to dissolve. Now I always put just a hair in more for good measure just to make sure, but I think I've got it pretty well set. At this point then, I'm going to pour it back into my graduated cylinder. And again, I only want the liquid portion. I don't want the undissolved solid in there. I also want to get as much of it as the liquid as I can. One more drop here I think I can get. All right, there you see I got a little left over there. That worked out about perfect. And now I see that my mass is up to 11.82. Mass of salt water is 11.82. If I look at my volume of my salt water, see if it's gone up at all. And it looks like it maybe has, but just ever so slightly. Okay, notice that really the volume, that salt that I added really very much just fit right back into the spaces between those water molecules. So my volume really is still at 10 milliliters. Now the mass of my salt is going to be the mass of my salt water minus the mass of my water. So I'll get my calculator out one more time. And I'll take 11.82 minus 9.38. It's going to give me 2.44, the mass of my salt. Now, solubility is how much salt can dissolve in 100 grams of water. Well, I was able to show that I could dissolve 2.44 grams of salt in 9.38 grams of water. So now I got to set up a little ratio. What is that? How does that compare to in 100? So now I got to do a little cross multiplication and division. 2.44 times 100, which of course is 244. Then I'm going to divide by 9.38. And I got 26.01. So my solubility is going to be essentially 26 grams of salt per 100 grams of water. And that's my answer. That should take care of us today. We'll see you back tomorrow.